I don't know if I
Right.
should click
So
the button because maybe I didn't. Let me check first. So I'm gonna remove the
okay.
stream for now. Yeah, I don't have. I can delete this. Yeah, I think I'm good. I think I'm good. Let me put the screen back on. Yes. So now we can talk.
All right. So let's discuss what we did last time. So the foundation that needed to be done was the AST. So can you go to the HTML?
Just changing the name of the stream.
All right, no problem.
Done. Okay. Just go to what? AST.
AST.ml. Yes. So okay. So this you recall, I guess.
Yes.
This is basically the baseline for which by which we're gonna be doing the logical layer in the database when it's up and running. So we have there the schema, which is essentially just a map mapping entities. And what is an entity? Well, an entity is just the elements that we have logically on our database. So, for
Yeah.
example, procedure, function, view, a table, all of those things they're just going there. And of course, tables, which is what we're focusing right now. Procedure is just there to just to signal that we're gonna do something with it later. But we have these types, which are basically the attributes inside of uh, the attributes inside of the table, right? So in a table we have another map, which is just a position, which is just a metadata for us to know how we're gonna serialize and deserialize things. So they
Yes.
need to be ordered, and the type, because that's basically the knowledge of how of what is the size of this thing when you convert to bytes, right? So for example, if it's an integer 32, we know it's 4 bytes. If it's a string, then we need to know the size inside the string, and
Yes.
so on.
Yes. Yes. Yes.
So that is the overview of this. Now if you go to IO, all right, so this is the convert table, which essentially just speaks we just speak a table. So you already know about the table. So you just pass the actual table there, which is that if you look at the type, it is an application of that type. So you read on the right first. It is entity table info with a
Oh, we're
field
talking about
metadata.
this thing.
Yes.
Okay.
So you're applying this to the type
Yeah,
T
it is the
inside the module.
same weirdness of F sharp. I remember that.
F sharp doesn't have this actually. I wish it did, but it
Are you
doesn't.
sure?
No, it doesn't
Because
because they.
I remember using both the
Oh,
angle
you're talking about the
brackets.
order.
Yes, I'm talking about the
Yeah,
order.
the order. Yes, yes. The F sharp also has it.
Yes, 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 yes.
It has like the other one, which is the .NET way, which is
Yeah,
like
the angle
option.
brackets.
Yeah. Uh, but what I was talking about is like the .t and constructing a
Oh.
module. You don't have that in F sharp because modules they're not functors. They're just like well .NET modules.
Well, I don't know what you mean. Like, I don't
Can
want
you go
us.
back to the AST?
I don't want us to go too much into a tangent. But could you explain what you mean by modules are functors in this
Can
case?
you go to the AST? So look at the map, for example. Look at there. We're doing module table info line 6 up. So we're doing module table info equals to map make, which is a module, and we're passing another module to it. So in OCaml, modules they are values. So you can actually pass parameters to modules and construct modules with different types. So for example, you can make a map module that basically handles, instead of strings, it handles I don't know, integers as keys, for example. So you see, like this is a way. That's why when we're doing the T there, we do dot T. So can you go back? Oh, that was one example there, but that's fine. So on line one down. So entity table info dot T, and then what we apply to this T? Well, we apply the entity dot field metadata. You see?
Oh.
So this is maybe confusing at first, but this is very powerful because well, like if you have good modules, man, honestly, I don't you don't need classes because in F sharp like they handle this by doing classes. Like they chose not to offer this support because well, you just have classes and you do virtually the same
Yeah,
thing with
yeah.
a hypermeter.
Probably the gains of inherent in C sharp would be massive.
I I mean, you can
Because
still have both. They just didn't.
no, but
I don't
that
know. Like
sounds
I
like
didn't
more work
implement
to
it.
me.
Yeah, I didn't implement it, but it sounded more like the justification I read from Don Simon. It sounded more like laziness, or he didn't want to because it would be a redundant feature. I don't know. It's an
Oh,
odd choice to me. It's a very
uh,
powerful feature, I think. But
yeah. So
anyway,
let me try to rephrase it. So you're telling me that modules are parametric.
yes. Oh, yeah.
Okay, cool.
Okay, so we receive a table, which is basically just a that map of strings to the fields. Then we have an attribute name, so the attribute that we want to serialize.
Oh, I remember what was the problem. The problem it was because in the first version we didn't want to pass the entirety of the table. We wanted to serialize just
Yes.
the.
Yes, exactly.
Ah, I see.
So, and the last thing is the literal, which is just a the actual thing that you want to serialize. So, what we're gonna do later is another function that's gonna fold over the table,
Yeah, man, that makes
and
sense.
this shouldn't be convert table. It should be convert literal, right? Something like this.
Sure.
Doesn't It's kind of wrong the name. So basically, what we're doing is just like consulting the table. So that's on the match. We consult the table and the kind of literal that we have in there, and then we just pick the metadata and convert it to bytes. That's it.
So bytes dot of string. This is what is this is a string. This is a function that converts the thing to bytes. Oh,
Yeah.
there's the weird bytes package or module.
Yes, the very inconsistent bytes library. Yes.
Oh man, I don't know. It's so. I want to use the
Dirty.
word refreshing, but it's so but I don't think maybe that doesn't fit. But it's refreshing to see the in again.
Okay.
Yeah, because usually when I see lets, both in F sharp and Rust, they're just like they don't have
You
the
know
in.
that in F sharp it's optional, right?
Yeah, yeah, yeah,
It
yeah,
still
yeah.
is there, but they removed it. I That's the thing that I want to say ideologically against, but I'm against moving because this gives you an insight about what the grammar is doing, about how the language operates. So when you remove it, it sounds like you're just doing statements, like it is
Oh yeah, yeah,
the
yeah.
wrong.
This
You
is
see?
you are completely correct. This in reinforces the expressions versus the statements philosophy.
And not only this, like for example, it gives you meaningful ideas about how the language works. So for example, you can do in F sharp and OCaml like intermediary expressions that yield unit, right? So for example, when you cause an effect in OCaml, you can end the sentence with a semicolon,
Mhm.
right? So for example, if you look at the line 4 down, there is a semicolon there. Why? Because that thing yields an effect. So look at the type of set
Yeah,
int
yeah, I remember
32.
that. I remember that.
So you see, so I added the semicolon there. So the same thing for the differently, like in F sharp in OCaml the same way in SML as well. You basically can have intermediary expressions that yield unit. If you have something that yields something else, like a number, like an int, it's gonna be ignored, right? Uh, and I think all of them implicitly ignore, but they give you a warning, if I'm not wrong.
That's actually
Uh,
not a bad like I'm not
but
saying we should,
but
but we could
mm,
add this same piece of syntax that already tells you, oh, this is probably doing some unit operations or just ignoring the value. We could add this to silverware.
I don't see much the purpose of this on silverware because it's like
It's a program.
yes, it's like yeah, it is a program. Yes, it is the same.
Yeah, but anyway,
All right.
I think it's interesting that they specifically chose the semicolon to just put that meaning. Like you can already take a look on the code in a glance and just
Yeah.
say, oh, that's cool.
So anyway, let's try to run this one top. So go to the terminal.
Yeah, but isn't that the bad one?
What do you mean?
We already tried doing utop
No,
few
no,
sessions
it
ago.
works. You weren't trying it right. You were trying to load it by yourself. Try to load like normally.
Wait, we changed the name of this function. Isn't it gonna break?
No.
No.
Oh,
Okay.
probably it will. Meh. I don't know if you're using on main though. I
Yeah,
don't think we are.
that's why I went to this, and I don't think we are.
No, we are not.
So
Okay,
how
so
did you test it?
just go. Well, I tested on utop. Go
Oh,
to the
okay.
terminal. So just try Dune utop.
Oops.
You need to install.
Open,
So
install, utop. This,
yeah. Oh man, hold on. You're typing utop. Last time I yeah. Oh man, these dependencies. At least it's all cached, so it's fine. Doesn't have to build the stuff like Python.
well, with Nix you can do that with everything.
Well, yeah, but some things are more hellish than others to build. Like for example, building Python on Nix is hell.
I
I
never
don't
tried.
wish that experience. Yeah, I don't. I don't wish that experience for anybody. Okay, so do Dune your top now. See. There it is, my friend. It's
Oh,
gonna pop up. There you go. So now open Camelot.
open Camelot.
There
Oh,
it is.
this time it worked. Wow.
Yes. Oh yes, it's not tabbed.
Oh, I
It's
need
like yeah.
to open Camelot.
Press just enter. I think it completes.
Too late.
Yeah. Oh no, it doesn't. Okay, so like semicolon, semicolon. Don't forget on
Oh
the
yeah,
rep.
the same. Oh, this bothered me a lot with F sharp.
Well, all
Okay.
right. So there's an explanation for this, but anyway, let's go. So now open the thing that you have. I think it's IO, right? And AST. So open both there. Oh, sorry. Open IO dot write.
Okay. Open IO. Is it capital letter?
Just the I. Every in OCaml, every beginning of the thing is capital letter, and the rest is not. So
Oh,
yeah.
right. I do have right. That's cool.
Yes. Just yeah. Now you could call this, but just open because there's some dependencies there. Just open IO
Oh,
write.
oh, you're talking about doing like that.
Yeah, because it's gonna import AST as well.
Okay, so
Semicolon,
there is someone
semicolon.
talking in the chat. I need to.
Oh,
Uh,
is there
yeah, yeah, but
somebody?
there's not. I wouldn't recommend taking a look at that.
All right.
Oh, this. Yeah, sure. So what else do we need?
All right.
I think now we
So
have the thing. Yeah, we do have the thing.
yes, I do. So just there's some code there. Look at the file. Just copy and paste to test.
There's some
Oh,
code
but change
there.
the name of the function, right? Instead of convert table, convert literal.
There is some code there. You're talking about this code?
Yes, all of this. This is just for testing.
Okay, I
Oh,
don't
you
know how
commented
to
again.
uncomment this thing,
Yeah,
so
controls. Yeah,
yeah,
one by
but
one.
selecting it didn't work for some reason.
Yeah, because he understood that you want all of them, and they're different.
So literal.
Literal.
Okay, cool.
Yeah.
So how do I do that? I just literally copy paste.
Yeah.
Okay, so control this.
I was thinking you were gonna forget. You have to open ASTs explicitly, I guess.
Mm.
Semicolon, semicolon.
I'm gonna forget this all the time.
Yes.
Okay,
Oh, okay. Now
okay.
the next. It's gonna fail there because it's on the module. That's
Oops.
fine.
Control Shift.
Is
These
the expression
expressions
of the
type
type
string, but
string
an expression is expected of type.
logical? What? This is. Can you go back to? Maybe that's why it's complaining. I did some poo poo.
Okay, so we need a table,
No.
dude. We need
Oh
table.
yeah. I think the table was there, wasn't it?
Oh, maybe it was the wrong shortcut that I used then.
Oh, okay. All right.
That
Failure
seems
not
wrong.
implemented.
That
That is
seems
very wrong.
that seems really wrong.
Oh, I
So
think I fixed this, but I didn't. Maybe it didn't commit. Uh, this happened with me, Nata. So it didn't fall into the first, and it is indeed a string.
yeah, so it
So
needs to be the second one the problem.
yeah, so
Needs to be the second one the problem.
Could it be the size again?
I'm very confused. Shouldn't this be name?
The second is the no, it is the table. Okay, it is, yes, it is the name, I think. Let me just look at what we're searching there.
Just try that.
Yeah, not yeah, name.
Oh,
Yeah, that's right. Because that's why we're searching, right? We're passing
yeah,
the name of
exactly.
the table. Yeah.
So, well, I don't know if you're gonna use the same philosophy of silverware, but we should have tests for this.
Oh no, yeah, sure. I agree. I
Yeah,
totally
you agreed
wholeheartedly
before as
agree.
well.
Well, I just don't want to do it, but yes, I agree. I'm gonna implement the test suite in OCaml. I don't want to in Dune.
uh, I don't have
Although
the
it's
knowledge you
already hot
have,
there.
so.
All right, so just copy the last one.
But this I think we need to do. Wait, schema.logicalmap.add.
Yeah, just
Oh, this is the
yeah.
this is the quote unquote name of the table.
Yes. So
Now it makes sense.
all
Awesome.
right. So now we can test. Like you just need you. I think you. It's hashtag reload. I think reload.
No.
No.
Well, we
Uh,
can try anyway.
let me see. utop recompile. Let me see here.
Recompile isn't a good word. Reload is better.
No, no, just I don't think it is recompile. Okay, people just say, "Yeah, man, just quit. Just hashtag quit and then open again." Yeah.
And then you can whatever the forum is, you can just go there and comment, dude, my language has this. What the f?
Man, this is
We have that.
apparently there's a watch thing, but who cares? Let's just quit and reopen again. It
Wait,
saves the
why do you need
commands
to
at least.
quit? Why do you need to reload? By the way, I didn't ask. I
I don't
should
know,
have.
like just when we start to modify and then we want to test, I thought it was easier if you could just reload and all your commands are still there. But if you quit and open again, your commands will still be there, so that's fine.
Oh, really?
Yeah.
How do I quit?
Well, just Control D or yeah, or exit, but then you need to pass a number
That's
like
bad.
one, like exit one. It's like C. Yeah,
Okay, cool.
yeah. You need to wait it to compile.
Okay.
Now, if you press up just to see, yeah. So the commands are there, so it's okay.
Okay,
Anyway,
so
so now we can start.
what do you want to test?
All right. So no, that was it.
Okay.
Now what we gotta do? Do you
So there
remember
is
the
a
folding
yes,
that I
but
mentioned?
okay, so what would be the name of that function that you're
So
talking about?
now that I think should be convert table, right? Because that's actually converting the table.
Okay, so let's convert a table. What should we receive to do this conversion?
So first of all, we
We need the
receive just
schema, right?
actually think of this. We're not converting the table, right? We're converting rows of the table.
So this is wrong.
Yeah, so it's convert row. Just
Row.
row, not rows. Yes. So you need to know what kind of table it is.
What do you mean by the kind
So,
of table?
oh, sorry. Okay, so I think I'll describe the procedure that I have in my head.
Sure.
We look into the schema,
So
given a name
mm-hmm.
that this row represents. So this row, we know that it's a row for table A. And then we pass the schema, and then you search on the schema for the type for table A, and then you see all the uh, we have now the information for the table, and then you go element by element inside the row, serializing this with the convert literal.
I have a question.
Okay, go on.
I understand the necessity of the schema. I
Yeah.
understand that. I just don't know, like, how do you identify a row? Is that gonna be an ID, like a number?
How do you identify a row?
Yeah, you want to convert a row. You need to
Yeah.
provide me the schema and the name of the table because then I can search that name on the schema.
Mm-hmm.
But I also need to know which row you want to convert.
Think of it. A row is a generic thing, right? It's just to think of a tuple in
Yeah,
a
sure.
database? It is a map, right? You're just mapping like a name for the attribute and the value it represents. Maybe if you want the type, I don't know. You don't need the
Wait,
type.
wait, 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 wait. You said it is a map between a name and a value?
Yeah.
It is a map between a name and a value. Isn't that a column?
It what I'm saying is the row is representing like every element of the row has a column attached to it, right?
Okay, I think I'm confused. Let me try to give you an example.
Okay.
So let's say that you have I'm gonna call a table, but theoretically speaking, then the proper name should be relation or whatever. So we have this, and we have, I don't know, color, and then let's suppose that
Oh,
these are the
comments by the way, because otherwise it's gonna be. Or go
uh,
to the scratch buffer.
no, we can uh, it is this. Okay. So then you have that. Then you have that. And then my question is, okay, let's finish this. So then you're gonna have, I don't know, a name, so Margita, and then I don't
Hmm.
know, 23, and then I don't know, orange,
Yeah.
and then what
I like the
what
orange by the way.
what do we want to convert is this?
Yes.
Okay, so do you agree that we can have multiple rows in the same thing?
Yes.
And then this. So my question is, are we going to pass to this function the row itself, the name of the
Yeah.
table, and the schema, or are we going to identify the row with another way, like a number?
No, you don't need this number now. That's a. I think what you're thinking is a row ID. You still don't need this. This is for
Yes,
later.
row ID, that's the name.
Yeah, that's for later.
Okay,
You can just consider it as being plain and simple a map of
so it is a
attributes
map.
mapping. Yeah, name, Magenta, age, 23, color, orange, blah blah blah.
Sure, yeah,
Is
so
this?
that's that I understand. So now I understand. So let's start. So we need the schema, you said.
Yeah.
So we need the schema.
We
Uh,
can change this later because this is gonna be kind of redundant, but you'll see. It's just like to construct things in a easy manner. So anyway, just pick the schema. So go to the AST. I don't recall what is the type. You're
uh,
gonna need to do schema dot t.
T, okay.
Yeah, and then you need to compose this t right with something else.
So
And what is
schema
that
logical
something
map?
else? So
No, no, no,
yes,
wait, sorry. Whoa, that was correct.
yeah. No, no, wait, yeah. It's the logical map is the thing that goes on it, right?
T. So we
The
are
opposite,
applying
right?
this to
It's
this.
no, no, no. Wait, wait. That's the opposite. So think of this. Uh, Look at the module there on line 7 and 10
Yes, I
down
looked
on the
down.
other
Yeah,
one.
yeah, 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 yeah.
So what it's saying there is that you have a schema, a module where you have another module inside named logical map that is just a map
With
of
the key being
strings.
a string
What do you need to compose? You need to compose this logical map to be a map of what?
of strings and this T.
Yes.
Okay, so it is
So you don't need
actually.
to apply anything in this case. It's just a standalone T.
Oh, it's already here. I see.
Yes.
Okay, okay, okay. I see. Okay, the next one we need a table name.
Yeah.
Excuse me. String. Next we need the row,
Yeah. Which is just a map with
which
the.
is map dot make
Ooh. Yeah. Now let's see how
string,
you're gonna do it.
and then we need a, a
This
literal.
gives
We
you a
do have a
module.
literal.
Yeah, but wait, that gives you a module.
Yeah,
What do you
yeah, yeah. I
do
need
now?
to apply. No, I need to apply another thing, like in here.
So you need to do dot t on the module.
Dot t. Which module? This
Yes.
one?
Yes. Dot t or type, I think.
I am very confused. Why do we need to do that?
Because this is giving you a module. You need to compose the module to use with something else. So you have just the first parameter and the second is parametric,
Yeah,
right? But
that's
this
why.
is not a type.
But wait.
This is not a type. This is still a module. Look at the example on the ST. There. So you're doing make, and then we are assigning this to table info. But then what do we do with table info? Well, we get the type inside table info, which is .t. You see?
Ah, wait. So can I say that every single module has a .t? Or
Yes.
am I the one going crazy?
Yes, that's right.
So this is grabbing the type of the module.
Yes, and it's parametric because you have another thing that you're passing to it, which is field metadata.
What does it mean to say that you are grabbing the type of a module?
Uh, well, it is just accessing as a namespace because at
It's
this point it
just
became a type,
access.
right? It is a module, and you just want the type of the module inside the module.
Oh, okay, I see. Okay, so let's actually do like that. I actually have a shortcut that I made to do this sort of operation, but I forgot
Yeah, I
already.
remember you showed. So dot t
Uh,
instead?
okay, so we want map.make.string.t,
Yes. I
and we
think
need to
there's
pass
type as well. Yeah.
something. We need to pass something to that. I believe we
Yeah.
need to pass
What goes
value.
in a row? It is a literal, right?
Yeah, so it is this.
I think yes, we're using value.
Okay, so it's gonna be st
Dot
value.
value. Yeah. There it is.
Cool.
This
Okay.
is this is kind of confusing. I'm happy you got it. All right.
Okay.
So now I described the logic, right? So what do you do? First thing.
You need to do a lookup on the
Yeah.
schema, and you need to
Hmm.
find the name of the table. So
Yeah.
match schema dot um, t
Okay.
dot find. Or am I doing things wrong? I think I'm doing
Well,
things wrong.
this is a schema, right? But this is what?
This is a module.
Look at this. You want to say what is actually the this is the thing applied, right? So you need to get the map. Yes. Okay, you got it.
Uh, we want this. We want the table name, and we need to pass the find opt, and then I need the schema. So this. So that. Cool. So now the question is, what is the return type of this thing? Oops. It is an
Uh,
option.
yes, it returns an option with the thing you specified to it.
So this is going to be a sum of some sort. It's going to be something in here.
Yeah.
And then if we find none, we're going to just fail with could not find table. How do
Yeah.
is it hard to do string interpolation?
Uh,
It
there's
is.
there's a with f.
What is the syntax for that?
Oh, just with f, and then you do the interpolation, like the not interpolation, like C, with masks.
I am a little bit confused. Where should I
What
put
do you want to
things?
What do you want to write first of all?
Could not find table X in the schema.
You want x is a string, right?
Yes.
So just do with f, fail with f,
Oh, it's in here.
yeah, and then on the x you put a mask, like a percentage. I think it's s, and then you pass the thing.
Like that.
Yeah.
Okay, this is. I don't understand why they chose file with F, but okay.
Oh, it's like a printf, print format. So fail if formatting.
Oh, okay. Now that helped. Okay, so what should be the thing enclosed in this? It should be the
All
relation.
right. Yeah, so we get a entity, right? So it should be table. So if it is something else, it is wrong for now. So instead of doing this, do the following: sum table. Do the pattern match deconstructed already.
You mean
This could be
this?
either a table or a procedure, right? Look in the
Oh, I see,
look
I
in the
see, I
other
see, I see, I
thing.
see, I see. I see. The entity.t can be two things.
Yes.
So how do I
So
know that I have a table?
well, just do table So
Table.
table, I think, no, not me in between, yeah, between parentheses only. Yes. Now capital table, and then you get the thing inside of it, which is the table metadata, like attributes, not without the dot, just table space. I don't know, attributes. Yes. Now
Okay.
you have another thing to complete this pattern match, which is the case of sum with something else, and in that case you just ignore. In this case,
Procedure.
Lemons, you can just do underscore and then remove this. Yeah, okay.
Yeah. I know we can do the catch-all, but well, that's not what we should do.
Yeah, okay. That's better to debug later as well. That will
Um,
recall us we have an incomplete
so
pattern.
fail with
Uh, No, you can just push.
procedures yet not implemented.
Okay, yeah,
Okay,
that's good.
cool.
All right, so what do we do on this one? Now that we have the metadata, and this is the type that we want to convert the literal, now we just need to loop through the literals, converting them to strings. Sorry, to bytes.
So I need to do a fold.
Yeah.
Okay, I need to do a fold. I need to do a fold with my accumulator is an accumulator of bytes,
Mm-hmm. The result,
and
let me tell you the result you want. The input, it's a fold with the convert literal. And
uh,
then the result is a list that is a tuple between the position of the position and the bytes of it.
wait, could you repeat the last part?
So, okay, I'll say it again. So we do you agree that to write the bytes we need to get in an order, otherwise we're gonna lose what we're writing to begin with.
Yeah.
So what you need there is that you need to split with the position and look at where we have the position. Line 10 up, for example. We're just not using it, but we have the position there.
We're just not using it, but we have the position. I agree.
So all we need to do is just slightly tweak that function on the convert literal to, instead of only returning a binary, we return a tuple of
Tuple
the
with the
position
position and
and the binary.
and yeah.
And then we just fold in a list and then sort the list by the first position on every element. And that's it.
Cool. So how do you? What is the? Oh, it is that the asterisk
uh, Wait, what do you mean?
is the to create tuples. Oh, the asterisk is only the
Comma.
type.
So parentheses and comma, yes. There's a difference between type and constructor.
Okay, so this thing actually returns a thing. So let's actually,
Yeah,
for
just do
now
a
at
let
least,
otherwise.
so let, I don't know, result
Ref. Yes.
in, and then we do this, and then we do pause result.
Position. Yes, that's it.
And then in here, this actually is still the same,
Yeah,
but we
this is
just do
modifying in place.
pause this.
Man, this library is so weird. Because sometimes it modifies like the thing, and sometimes it doesn't. I don't know. This is strange.
Okay, but that change was easy. Cool.
Yeah.
Now,
Now you
actually,
need to do.
actually, serialized value.
Now you do a fold on what?
We do a fold on the metadata. No, we do a
On,
fold on
by
the
which
row.
type?
Sorry.
On the map, right?
You're talking about this.
Yeah, on
Yes,
the
so
map of the row.
that's the
So
row.
I
That's
think
the
it
row.
would be a good idea for you to make a type alias of this and use it inside, because if you're gonna need to
How do you do
construct
type
that,
alias in OCaml?
just type equals another type.
Okay, row this
Types are lowercase, by the way.
cursed.
Yes, I don't like it as well.
Um, okay, so this is a row. Oh man, this is.
Yeah, just bear with it.
Okay,
Okay.
so now we do the fold. So I'm assuming map has a fold. Um, it doesn't seem to have a fold.
Now, wait. Now you need to do this on the row, right? So row dot. Just a second, Lemus.
Maybe it's getting confused because there are two rows.
Sorry.
Maybe it is getting confused because there are two things with the same name.
It could be. Yeah, probably that's the
Oh.
case.
No, I don't have fold.
Oh wait, that
Do I
is
have
the. Oh no,
far?
never mind. I'm saying bullshit there because it should be map dot make dot well string dot t dot. You see? Because that's the type of the module, but you don't want that. You want the make string and then dot and blah blah blah. Yeah.
And here we have the
Yes. Now
fold.
try. You
LSP
still
saying
don't
no.
have it. That's
Okay,
strange.
so let's search for that.
No,
So
that's based
fold
on the type. You shouldn't
map OCaml.
like look at the example we did up
Okay, so
there.
people is talking about a thing called map.fold.
Yeah, but look at the example he gave up there, like on the line 16 up.
16 up.
We're
Here.
using yes, we're using entity.tableinfo.findopt, right? What is table info find
Oh,
opt?
oh, you're right, you're right. The
You
people on the
see, so
internet
it's not the
says.
type inside; it is just the module.
Okay, we can just ignore LSP.
Yeah, let's try. Unless maps don't have fold, which would be cursed.
No, 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 they do. According to Stack Overflow, they do.
Let me see.
Not having like I don't know what Nathan is doing if they don't have a fold.
Okay, it has a fold. Unless I can cringe less. Okay, so I still think this is wrong though,
I don't
because
want to
this is.
implement a fold. I want to use a fold. People are teaching me how to
Mm,
make a fold.
I still think we need to apply this because that's weird. Oh well, never mind. We're not doing this on the other. Yeah, that doesn't make sense. Yeah, that seems right to me, man. Because map gives you a map.make and then it pass a thing gives you a module and then you're doing dot fold, which is accessing the thing inside the module.
There is a thing called map S.
What is S?
I have no idea.
It as well.
Uh, uh, just documentation. Finding at random. Okay, so we don't have a fold? Are you guys kidding?
No, you do.
Jane Street has a post on it.
Oh, they have their standard library as well.
Probably, yeah. Probably it is saying they start
Here,
with
like
Haskell.
the dude is doing exactly the same thing. Like map.make and then pass a string to it and then dot
Yeah, so
fold.
let's just screw it. Let's just ignore LSP. I don't really care. So make
I
string.
think I see the issue. Do the following, Lemus. Do module. Okay, that's kind of cursed. Do module like row. You see where you're doing row up there?
Oh, you want to do the trick in the Stack Overflow post
I don't know if that's the thing.
using I don't know.
Well, row.
OTF map
Yes.
make
I think
string,
that's why it's not recognizing.
and then we can just
Yeah.
do WTF dot fold.
Okay. So that was the issue. So move it upwards.
No, first the name.
Um, I don't know what should be the name for this. Literal map. I don't know, man.
I think the name in the post is okay.
String map. Yeah. Move. Do the following then. Do move that up before the type. Yes, and then just use the string map dot
Oh,
t.
cool. That's a good catch. String map. Okay. Okay, so let's go to string map. So we want to do a fold. So I noticed in the post that the guy is doing some sort of this.
Yeah, it's a lambda.
Yeah, a lambda. That's fine.
So yeah,
Not too bad. The first element is the
it's
key.
the ACC, I guess.
Key value
Oh yes, never mind.
ACC.
Oh, but wait, isn't the ACC first?
Well, I have absolutely no idea. How can we ask the utop the type of things?
Yes, you can.
Okay, let's do that.
I don't know if that's gonna help because if it's just gonna give you the type, but if they're all the same, then it doesn't matter. But, but well, try.
No,
Can
they
you?
shouldn't be all the same because that
I'm
means that
looking at
everything is
the.
bounded to be the same, which is not
Oh,
true.
okay. Right.
So how do I ask for types? I forgot already
Well, you
in F
just
sharp.
type the expression
No. Okay, so map, make.
string.
Oh, we're gonna have to do the whole thing again. So string map map make string. Okay,
Okay,
cool.
there it
Thank
is,
you.
the entire module.
Thank you. Fold. So it is the accumulator at the end, it seems. The key is the beginning. The value is it comes after. Um,
Yes. So it is like a list. So we are applying another thing. So AT is like, for example, the map, right? In this case.
the map.
It is the
Yeah, this is the
key.
map. The key, and then I'm assuming this is the value of the map. So this needs to be
Yeah.
the accumulator, dude.
Yeah.
Okay, cool. Um,
That's
then
weird. Why it comes first? Good question.
in F sharp it's the opposite.
Yes, it always comes like F sharp, at least the standard library, has a standard on everything. Like things are named exactly as they should, like, and they don't change.
Okay. Anyway, so
Okay, so
let's. Um,
well, just convert
boy,
literal.
are you sure we should not already start to add options into this thing because
Yes, we should, but let's not. Let's ignore
but
it.
the problem is that if we keep doing that mentality, we're gonna have a stack of
Dude, let's
things.
just. I just want to see it working, and then we go back to this, and then we add
Do
the
you
option
promise?
there. Yes.
Okay. So we want to do a let, right? Can I do just
You
deconstructing
don't need
already?
to, but yeah, you can. But why would you?
Serialized value, because
But
then I'm
why
gonna
would you?
use, at least for now, for teaching purposes.
Okay.
Then I'm gonna call convert literal. Then I need the table.
Metadata.
So metadata.
This is a weird
I
name for the table, but
okay
okay.
no. So let's change this to table info.
Yeah, that's better.
Table info. Then we need to pass the attribute name, which in this case will be the I forgot.
That's the attribute you want to encode. So that's the key, right?
The attribute I want to encode. That's right. That's the key. And I
And
also
then
need to
the
pass the
actual literal,
value,
which is the value.
which is the value. And then
Okay.
this is gonna return to me what? This is gonna return to me the position in which I should serialize that.
Hmm.
It's gonna tell me also the binary that I should save for later. Right.
Yeah. And then you just need to append this to the accumulator.
We're gonna organize the accumulator later.
Organize? What do you mean?
Yeah, because right now it's a mess. Because the position, maybe the first
Oh
one will
yeah,
be the
we need
last.
to. Yeah, yeah.
I
We need to.
That's actually a good opportunity for a priority queue.
Uh, well, I would say something dumber like array, and then you just apply it.
Yeah, but then we're gonna have to sort later, dude.
No, an array you don't need to sort. You just insert on the position, and that's it.
Oh, okay, that's cursed, but that's fine.
Yeah, but let's just do a list, dude. We're gonna
Um,
have to go back to this anyway.
okay, so how do you do append in lists? List.append?
It is well, you can do
Ooh,
this, but you can just do.
there's a thing.
Uh,
Oh,
that's
append is
not the
actually
auto.
not what we want.
You actually want to concat, right? So you want like a whole like at. No, sorry. That's not the concat you would think of.
Yeah,
It's a
no, the
different
type
one.
signature is completely
You see
cursed.
the at on the other one there, up there,
Is that the
line
cons?
9. Line yes, but no, that's not the cons. That is like the dollar sign in Haskell.
Ah,
So the cons is only one. It's like just a at. So one list at another thing.
okay.
Another
So
list actually.
no. But how do you do cons, dude?
Yes, that's it.
Okay, so you're gonna do this cons. So this as ACC.
Well, then you cannot dismember, right?
Yeah, no. But for now I'm just gonna nuke this convert,
Yeah, convert literal.
and
And
then we
then
can
they
just
need the first needs to be a string, so that's not there's no cons as far as I know. So you just need to put this as a list.
wait. How do I need to convert this to a list because there's no
Yeah,
cons?
as because the cons that I know that you know as well, which is the column, that is for pattern matching. I don't think it will work as a constructor. I don't remember it
Cons
working as a constructor.
operator camel. There's no way. Um. Okay, so I think it's column.
Oh,
Me-
that indeed works.
I think it's
Mm,
column. Oh,
yeah,
cool.
it is. Okay, I thought that was just for pattern matching because I don't remember using it on F sharp though.
Okay, so we're gonna indent
Yeah.
this, and then we need the thing to go there. So what do we need? The row.
You need to pass the accumulator first, I think.
Oh, so this is
So
an
an
empty
empty list.
list. How do I do that? Like
Mm,
this?
yes. Or you
Really?
can do the list dot empty.
Okay, let's do the
Oh
prob.
wait. What? Wait. No. There's no way.
What?
What is he complaining? I don't think
Um.
there is the list empty, by the way. I don't think.
Okay, so it needs to be
Yeah.
this.
Yes, but it's complaining. Change the order. Man, this is cursed. All the orders were
Why,
swapped.
dude? This is bad for composition.
Yes, this is horrible, man.
This is so bad. So bad
Man,
for
what the?
composition. So bad. Is this
And
written in
what is
here
it
and
fading on the
we
with
lost
F?
it?
Sorry.
Fold. Yes, it is cursed.
Yes, it is on the opposite. Oh, dude. Damn
Why?
it, man.
Why?
Okay, so on 4, why is it fading? On fail with?
Unbound variable.
What? Are you joking me? That
O-
doesn't exist in
Okay, so
OCaml?
fail with F.
Or is that just an F sharp thingy?
I believe there's a chance. There's a chance.
Okay, I know a solution, but that you're gonna cringe really
Oh,
hard.
wait. So, print. Uh, how do you ask that for in Google? Interpolation. Interpolated error messages. OCaml.
Well, I think you're gonna need. Well, we have PPX, right? So
Wait. Wait. I don't want
yeah,
to
Lems, I
see.
think
I
you're
don't
gonna
want
need
to
to use
see.
the S printf, man. Ah, man, just change that fail with F to S printf, and then pipe to fail with.
Okay, so s printf, which I don't know if
Uh,
exists,
printf dot
and this is not pipe. This is pipe.
yeah. Change dot. Sorry, printf dot. Yeah, there.
And they couldn't make an
Cursed.
alias for this.
Yes. I mean, that is. But dude, like, there is no like composition like uh function as well. Like, you need to define a lot of stuff like that you have for granted.
Yeah, yeah. So yeah, I guess in this case, at least for now, in terms of composition, Haskell is still the king in my mind.
All right.
Anyway,
So
so let's see. Let's see.
that is very simple code actually. That's better than my first implementation, by the way.
And by the way, this lambda in Haskell would be. How do you do that? No, not that. Oh, you
Uh,
need to do
there's
this.
no yes, there's no single line
Okay,
comment.
in Haskell that would be dot convert literal. Done. Function composition king. Anyway, um, so what do you need to do now? How do we call this stuff?
Oh,
Top?
do you want to try on the top? Yeah, let's go.
Sure. I do have my comments
Did
in
you
there.
save?
Yes,
You
I
didn't
saved.
forget to
I
save.
saved. So,
You can just press Ctrl D. I think it kills the thing.
unbelievable.
Yeah, kind of cursed actually.
Unbelievable. Cool.
Okay,
Okay,
now
so now we need to do the. Oh man.
should
Open.
get the script to do all of this, right?
Yeah, we should. Um, no, that's not what I want. We need the. We
IO
need
dot write.
table. Cool. Then we need the X using name. Yes. Uh, no, actually, we don't need
Don't we need to
this.
import IO dot write first?
Oh yeah, that's true as well. I forgot. Okay. So now we need the schema. This.
Okay.
Now we're gonna do the let x equals convert row. Actually, should make the row first. So how you accomplished this the last time?
String. So you
Ah,
need to do a string
ah,
map.
man, the things are hard.
Yes,
Things
man. Why do
are
you think?
hard.
You think everything is just
Okay,
rainbow?
row. Then string map dot empty.
Mm-hmm.
Then string
String map
map add um,
person. Yes.
person. No. The row needs to have Magenta.
Oh wait, that's the key, which is the column.
Oh wait, sorry. So this is name.
So it's name. Yes.
And then I need the other thing. So I need
The value.
this.
Yeah.
So this is
Yeah, but
where.
it's a not really right. It is a value. It's a v.
Oh, I
I
need
think
to
it
do
should
the
be
other
string.
thing. I need to do the other
Ast
thing.
dot.
Where is that? Where is that? Oh, I don't have it in here.
Look at the code. I think it's just v string
V
value.
string. V string. V string.
Yeah. So ast dot v value dot v string. Then the name.
And then we put Magenta. And then we should pipe using string map
Oh, you're gonna do two of them. Okay.
age.
There's no age on the schema. I think.
Ah, no, that's fine. But
Yeah,
this
you
change the
can just
schema is
add it
fine.
later.
Yeah, change the
Yeah.
schema is okay. So v integer and this.
Hmm.
Um,
I'm
that's
24, by the way. But okay.
okay. That cool.
All right.
Now we need to change the schema.
Yeah, just add pipe again and add. Oh, but
Uh,
uh,
logical map.
yeah,
Oops.
but wait. That's not where you should do, right? You should do on this on the table. This the table on the
Ah, I
schema.
see what you mean, and I'm sad.
Yeah, there.
I am sad. Okay,
You need
this.
to add the position as well. I
Uh,
recommend you just copy the last statement and paste it there. It's gonna be easier.
I think I agree that it's gonna be easier, but it's good to for practicing typing. Because we need to type fast, and I already got. Okay, my Emacs shortcuts are broken. Thank you, Top. I need to
That's
do in the
normal.
caveman way. Thank you.
Even yes. Grug
Okay, so we're gonna do
age
age
and
one,
then one
and this
type.
is actually t integer. Do you have t integer by the way?
Yes.
Yes, t integer 32 also.
Doesn't take a size. And it.
Is this correct? Do you have a semicolon? Yes.
Yeah.
Entity field metadata blah blah blah. So that's it. Cool. Now we need to do the schema.
There's just a type annotation, by the way, to help the thing. Okay,
Uh,
so find the scheme again with the table. Yeah, run this.
no. We need to also add
What? No, this is the table, man.
Oh, we are calling the name of the relation person. Yes.
Yes, exactly.
Then we do the row. The row
Yes.
is already there, but that's fine. And
Yeah.
now we do the thing. So
Yes.
convert
Mm-hmm.
row. What are the things? We need to pass the schema, which for some random reason is a function.
Yeah, I don't know why I did in a function.
Which by the way reminds me, is this how I apply unit?
Yeah.
So it's the same as F sharp, cool. And then we need the string, so I'm gonna just put the string is what again? Oh, the table
It's the
name,
name of the
person.
table. So person, yeah.
And
And
then
then
we
the
also need the
final
row,
row.
so row.
So the map. Yeah. Uh-huh. Uh-huh.
Okay,
Let's just
cool.
count the letters just a sec. I think the size. What size did you put for the string? 10.
Uh,
So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's perfect.
cool.
All right. So now we just need to sort to make sure that we are sorting this by the first position and then write on a file and then recover it. That's the hard part.
Yeah, but
So let's do it.
before doing that, I would like to first check
Okay.
if you can exploit the tuple,
That, yeah, it's kind of
like in
smart.
Haskell. Um, is this how you do lists, by the way?
Yeah.
Cool.
But
So,
you're gonna, yeah, I know how you do it, but I think you're gonna cringe a bit.
no,
Oh no,
this
that's
shouldn't
easy.
be
Check if
should
you
not
have
be.
like check if you have FST and do a tuple like want you.
Wait, I want to send this zero message. This expression should not be a list literal. The expected type is. What is the
Expects
list dot sort expecting?
I think it expects a what? A function maybe?
Oh, it doesn't have type
Yeah.
classes. I forgot.
Yeah, that just expects a function right before. It didn't
Oh
pass it.
boy. How? Why do we need to return an int?
Uh don't Oh, because of it could infer the int. Oh, that's a good question now. I don't know.
I'm thinking bad, very
I was
bad
going to
things. I'm
say, okay,
thinking
they
very,
could
very
infer the
bad.
int on the tuple, but no, it didn't. Like, I don't know.
Yeah, so I'm thinking very, very, very bad options. Like C options. C-like options. Why this needs
Ah,
to return an int?
just, just check what I said, like FST, and then do a tuple. Want you?
Oops.
Yeah.
Huh, that was weird.
Okay, so you do have like you can extract elements of the tuple. So FST, SND, 2 second, blah blah.
Now
So okay,
imagine that would be the case.
yeah. So you can just extract like this. I think there's a third as well, as far as I recall. There's until 4. I think you have.
There's a fourth?
I think in F sharp there's a fourth, if I'm not mistaken, and then it
Fourth.
stops there. No.
Okay, what about a third?
Yeah, but it's probably like 3 letters. You see, like TR,
Oh,
THD.
okay, so let's go THR, you think?
I don't
HD?
know. No. Uh,
THR?
third tuple element
That's kind
OCaml.
of weird, but I
Oh,
guess it's
there's an
fine.
nth. Okay,
Nth
that
makes a
also
lot
exists.
more sense. Nth.
Yes, nth, and then you pass a number.
Yeah. Anyway, so I want
All
to
right.
discover
So
what is this first.
yes, see if on the list what else you have. See if there's a sort by there.
No, if this is that it shouldn't because this is already
Yes,
sorting by.
yes, I know, but let's just see. I don't know. I don't trust
How do
OCaml.
I do stuff?
List dot sort and just start typing. Sort unique. That's a terrible name.
Okay, so we can't ask for the thing. So this sort OCaml. Module list, thank you. So the sort, where is this? Where is this? Fold. The names are just as bad as Haskell's. People, you
I
need
don't
to
know what
copy
you
the
were
great
expecting.
stuff. not the bad part. Sorting. Great. Sorting a list in increasing order according to a comparison function. The comparison function must return 0 if its arguments compare is equal. So it is as bad as I thought. It is C-like.
Man, I think I understand why, because think of this. I think I know why. Because, like, in why can you do, like, for example, in F sharp and Haskell, I guess, because you have a comparison parameter, right? You have an order
Yeah,
to the
constraint.
element.
Yeah.
So on OCaml you don't. So I think there's a function called compare. I think search for compare.
Compare.
I think it is exactly what we want. Compare. Yes. Yes. There. Yeah. So we need to use that. That's cursed. Okay, so we would need to compose compare with a top with
With the
first.
firsts.
So do the following.
Oh man, in Haskell there's a function just. Oh man, it would be so
So do
beautiful.
the
But
following.
okay.
Do let equals. No, sorry. Let no, not equals. Open parentheses. Uh,
Oh,
uh, you know the symbol from like greater. Yeah, that's composition F sharp. I just want to do the same. So equals. Oh, sorry. Two parameters you receive. So F1 and F2,
wait,
and then you
OCaml doesn't
just
have the composition?
no.
Ah.
So you need to do it yourself. Then. Okay, now you just do the composition as you would think.
Um, what do you mean by just do the composition?
Well, how is a composition?
Well, you pick the first. Well, you pick a thing,
Mm-hmm.
then you apply the first to the.
You need also a value, right? Sorry, I forgot.
Yeah,
Yeah.
yeah, yeah, the
Okay.
x. Yeah. So then you do something like that.
Yes.
But I don't know
But
which
look at
order we should do that.
yeah. So when you do in Haskell, what you're used to,
Right to the left.
right to the left. Yeah. Okay, that's strange.
Okay, that means that. But let me be clear. So that means that if I have this,
Uh-huh.
F2 is applied first.
F2 applies first. Okay, so let's do F2 being applied first
No, no, no.
as
But I
well.
want to go the F sharp way. So if
No,
you do
no,
this
the
in
F
F
sharp way
sharp,
is that.
it's the opposite, right? You do
No,
apply
no,
F1
that's right.
first.
No, that's right. Oh, sorry. Never mind. Yes, that's true. So the
Yeah.
F1
Yeah. So
is
this
the
F1
is the
and
thing
this
that
F2.
actually gets yes.
Yeah. So this is what we want. Oops. Okay. Cool. So
Okay.
now,
Now compare
uh,
who composed this garbage.
we also need an. We also would be. It would be great to have a thing called the own function. So let me show you what the own function does.
The own.
Yeah. So Hugo. It is a very. This is exactly one of the particular cases where own is useful. So on does the following. It picks two things, you see,
Mm-hmm.
and then applies a function to them, and then picks the result of these two and combine again.
And combine again.
Yeah, so for
What is it?
instance, in here you have a tuple, and here you have a tuple, okay?
Yeah.
Then you apply it first,
Okay.
and then you apply compare.
Okay.
What will that do? That will pick the first from both of these two values and
Mm-hmm.
combine them using the compare.
I yes.
So in our case, we want to use
So that doesn't
the.
eliminate then the second element of the tuple, right?
Oh no, in this case you are eliminating, but I thought we wanted that. If you don't, then just
No,
forget
we
about it.
don't. Because the second is the bytes, right?
Oh, okay, okay. But anyway, so for here's an example of how this works. So
Let me see.
you
So
pick f, apply to x and y first,
mm-hmm.
and then the results of these two operations you want to combine them again, and then that's what the plus is doing.
Mm-hmm.
And then my boss taught me this function, and it's surprising the situations in which you want to do that. You want to pick two things, apply the same function to both, and then combine them later. And but in our case, this is not enough because we want to preserve what is in the second member of the thing.
Mm-hmm.
Awesome. So Um, so let's try. Let's try to do that. Uh, okay. So what would be the first thing that we
So
want?
pipe the result of
Oh, we
this
want to
code.
sort. We want to sort.
Yeah. So pipe.
Pipe. Oops. Pipe.
Oh no. Yes. Okay.
So now we want to do a list dot sort,
Yeah.
and now we need to make the infamous functions. Can I do the pattern matching here
Compare.
already?
Wait. Why would you do a pattern matching?
Because we can extract the positions and the bytes.
No, but you don't
Okay.
need to, right? You can just do compare, composed with first, and then that's it.
I just do compare compose with first.
Yeah,
I just
because
do compare
the
compose. It's the
first
opposite, right? Because in our schema, with the F sharp way, you actually
compare
apply
will
the
be
first.
applied
So
first.
it's yeah.
Oh yeah, so
So it's
yes, it's
first
the opposite.
compared with the yeah. But the fact that you mentioned the reversed
Yes,
lets me to
yes,
believe that.
yes. Let's do the opposite.
Okay.
Yeah, but now you need to copy this code and paste
Yeah,
there.
yeah, yeah. We need that's gonna be. Let's do that. So
Utils,
Control F,
legal.
F sharp.
Até will cringe when he sees this. F sharp ML. This is heretical, actually.
So let now we can go there and copy. Okay. So now we do this. For some reason it
What?
broke. So
Yes, I don't know why.
so that 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 and then uh, the way that we're gonna do is from the right to the left, right?
Yeah.
Okay, so it's
So
F2.
yeah,
No, it's F1,
F2. No, F1 applies. Yeah,
F2,
F2
and
inside.
this, and that's it. So what is it complaining about? Do I need to do some
Uh,
sort of module stuff?
no, because the file is already a module.
What's the problem then?
But I think you need a semicolon, if I'm not mistaken. Oh, just doing build. Just doing build. Just ignore it. Yeah. Yeah.
Okay, but let's
Okay.
actually use that in here. So it's gonna be, oh man, so
Yeah.
much better. It's gonna be first, no,
Oh, F sharp.
compare this. Yeah, we need the. Let's
Yeah.
open F
Open
sharp.
F sharp build. Yes.
Let's open F
Yeah,
sharp.
this is cursed.
No, we are adding functions that we need, and we are giving credit to where credit is due. That's what you're doing. So compare this first.
Okay. Now
Do
build
do
to see.
D Dune build, and it doesn't work.
Unused open what?
This expression has type blah blah blah.
Wait, so the type tuple A to B, A and B, and to A? Oh, wait, but an expression was expected. So the compare, oh man, the compare has two parameters. Ugh, cursed.
Oh, so that's why I
So
wanted to use their own then.
yeah, okay, that makes sense why you need the, yeah, never mind. I thought, okay, I was thinking of another thing, but that's true. So the compare, you need to do a full pattern match and apply to the AB to the, yeah, that's
Uh,
cursed.
okay, so let's go. So this and that.
There is a, you know that in F sharp there is another operator that should do this, which is a double pipe thing. It dismembers a tuple into like it uncurries basically. But anyway,
Oh,
let's just do it.
okay. It's just for now. We can make this
Yeah.
better look better later. And we always say this, and we never do it, but that's fine.
Yes.
So what we need to do is to do the compare first. No, yeah, the
Yeah.
compare first because
Yeah.
we already did
Compare
the
just applying P1, P2.
P1, P2. So we actually don't need those. Actually don't need those.
Right.
Oh man, the on would be awesome. It's exactly, but okay.
Ah, yeah, you're
Uh,
dismembering. Yes. That's... Oh, do you want to do it?
no. Um, let's see if it works first. Okay. It does stuff. I don't know if it works, but it does stuff.
Can test that
Um,
top again, but let's not do it now.
yeah, I think
Quit.
we can trust that this is working just fine.
Yeah,
Um,
compiled it works.
no,
So
that's not why.
that's a lie I want to tell myself, okay? So okay, now that we have this, let's write. So open a channel.
I have no idea how to even start doing that.
Okay, we did already on main, something similar. But this is different because we need to do a byte channel. So let me see here.
How
Here,
much time do
file
you have available?
manipulation. Sorry?
We have plenty of time. Go.
Okay, so what you're going to do is open a channel first. So do another function like
Let's
write a
actually,
file,
yeah,
something
let's
like this, I believe.
actually put that in. And I think we made a mistake. We should actually call this.
These are all the fun serialization, I don't know.
Okay, that's fair. But we
Serialization.
are actually not using. Yeah, that's actually a good thing. Serialization. And then, oops, and then down here, then we're gonna do the module write equals struct,
Let me
and
check this
that will be
by
the module that will write to disk, write and read. Well, only write in this case. Only write, yes. Only write? Hmm. Yeah, for now I think that's okay. Go.
Let me just see here how do. Okay. Search for bin underscore open.
Bean underscore
No, underscore, like all lowercase.
bean underscore open.
Or open underscore bin.
Bean underscore open OCaml.
No, the opposite. Like in.
Open bean?
Yeah, open is underscore bin. Open out bin, I think. Probably.
Open out
Yeah, output.
out bean. Module stdlib.
And this is
Uh,
so confusing.
okay, so we want open, whatever that's
Oh
supposed to
yeah,
mean.
it is this. It is open out bin.
Bean. Oh, okay. Same as open out, but the file is open in binary mode so that no translation takes place during writes. And on operating systems that do not distinguish between text mode and binary mode, this function behaves like open out. Why? Well, that information is fine. I wouldn't say that that's not useful to know. Okay, so what we want to do is to actually open stdlib then. Open stdlib. Yeah, thank you. That's what we want. So let's write on disk. What we want to write on disk, Magita?
So you want to write in order all the bytes you got from the previous one.
No, yeah, but let's start
I
from the
don't know
beginning.
why make another module, by the way. Like, it could be on the first, because it's still part of the serialization, in
Okay.
theory.
Okay.
In theory. That's the
That's
important
fine.
bit.
That's fine. So write,
Alright.
and then in here we're gonna do another let write on disk.
Mm-hmm.
Who is there?
Nathan.
Hello, Nathan.
He came in the right time to enjoy OCaml. I bet Lemos is loving it, having the time of his life.
Uh, okay.
Imagine a Lisp. Imagine a Lisp-based OCaml. Imagine how awesome it would be, Lemos.
Can you repeat that? Sorry.
Imagine a Lisp-based OCaml, like a Lisp, but with all the inconsistencies you just saw.
Yeah, I see what you mean. I see what you mean. Anyway, so what do you want to write on disk, by the way? We
All
want to
right,
write
so we
what?
want to write the binaries in order.
No, but the
So,
binaries from where?
what do you mean the binaries from where? You're gonna receive a map with the result of the convert row.
Shouldn't we make like write on disk schema or write on disk table or something?
Well, yeah, but you do the
What
name
is
then.
the...
Dude, just do the annotation. We fix the names and all the stuff later.
Yeah, so
So
what I
just
wanted,
receive. Okay.
to do is write table on disk. And then we receive the schema
Okay.
and the name of the
Yeah,
table and
but we
then
don't
done.
write a table, right? Doesn't make sense to write a table. You write rows.
Yeah, but what is a table composed out of it?
Rows.
Yes, so?
You write rows, not tables. So even the name, like I don't agree with the name.
Well, I don't understand if a table is composed out of rows, why we can't call that table,
Because
but
it could mean that you're writing the whole table, which is not true. You're just writing one row.
okay, so we're gonna write, that's what I wanted to know. We're gonna just write one row. Okay.
Yes, one row at a time.
So we're gonna need to
So
receive the row that you want to write, and that's it?
yes, actually not really, right? We want the result of the convert row, which is a list of int bytes tuples.
Oh yeah, the alias is wrong.
Serialized row, that's the name you want. You could make a type of this.
Yeah, let's make a type. Let me see if Nathan said something on the chat.
Yeah, I'm reading
Enjoy,
here.
Maget, just write something else. What? Serialized row. Okay, so this is a list of what?
This is a list lowercase, and then you do the tuple before.
So it's gonna be a tuple
Int,
composed out of an int,
int, yes, bytes.
bytes. Do I need parentheses?
Parentheses. Yes, sir.
Are you sure
Now,
this is
why
how it
is
worked?
bytes? Oh no, you did a module. It's a type.
Oh, sorry. Okay, it seems to be wrong
Lowercase.
still. Oh, this, and I
Yeah,
guess this.
that's it. Yeah.
Cool. So
Now,
now,
just annotate the converted row to return instead to force the alias instead of the yeah
do I do that?
serialized row.
Yes, I do
Okay.
that like that. Cool. So now I'm gonna pick this serialized row,
Mm-hmm. And
and
you pick a
I think
well.
we need the schema and the table name anyway.
Yeah. So here's the thing. Did we implement this? Can you scroll down on this on the other AST ML? Uh, okay. On the schema there, we can make a function that basically picks the schema and then it gives the full size. Because think of this. Right now we are not updating, right? But in the future, it would be ideal that we wipe the space before we actually start writing on disk.
Oh, that makes sense.
Because yeah, there could be trash there, right? So let's just write dirty and then we do this function and then we just add it before
Yeah,
one
yeah,
step before.
supposedly.
Yeah, no, yeah, we should do it. But if we do, that's wrong. But okay, so now you just receive the schema as well.
Yeah, the schema. Schema T and the table name,
You don't need the. Yeah, okay, yeah. You need the table name. Never mind.
and then that's it. And this
Okay.
should be this. Oh,
Yeah,
should we
yeah,
have? How are we
unit.
gonna
It's
save the
literally
file, by the way?
how you're gonna save the file.
Yeah, so the files we're gonna generate the names of them randomly on the disk.
Yeah, so the easiest, dumbest way to do is to just write the name of the entity dot a format you want. Like I don't know, SQL Server is like the entity is ABC, like a table ABC dot NDF, and then it just writes the stuff for the table ABC there. And if
Okay.
you want, you can have like ABC one,
Okay,
ABC
we can
two,
use the table
ABC.
name for now. That's fine.
Yeah, that's
Okay.
the usual approach actually.
Okay. So cool. Now we need to get the
We should, by the
serialized.
way, all we're doing, we're gonna have to re-implement when we do a committer, like a transactions. If we go that far, I don't know,
Uh,
because you would just write to the disk if you are sure that you are committing a transaction, because otherwise you need to roll back and there's all the
Okay, I just noticed that this should be this, and serialized row
No,
should
wait,
be
it's still
convert
serialized row.
row, schema,
Oh, okay. I'm gonna call it.
table
Yeah, in theory, you
name
should have already serialized, but that's okay.
in.
Yeah,
Cool.
okay.
Now we need to do the channel thing.
Yeah, so now let do out OC is out channel, or do a better name, man, like output channel, something like this.
std.
I don't think you need to import anything.
Oh really?
No.
Okay. So can you repeat that? Sorry, I was thinking about
Do
the
a good.
import.
Think of a good name, but like output channel or like the file. It's like a file descriptor.
Mm.
IO channel. It's not IO, right? Because you're just writing. Okay. So open. Thank you. Open underscore bean. Oh, out bean. Sorry, that one. Yes. So now you just pass a string, which is the name. So let's do the following. Let's write on the specific dir. So write on temp for now, like slash temp tmp. Yes, you're getting the gist of it. I still need the printf before. Yeah,
And
printf.
print. Oh, the printf module.
Okay.
Why are we doing the temp? By the way.
Just a way that like Linux trashes files.
Yeah, yeah.
Because
For
if you don't write
later we
there,
add the
like I
temp.
assume, yeah, if you do this, I assume that it will write where you are executing, which is
Yeah, and which
inside
is what I
the
want.
underscore build blah blah blah. So I don't know, it doesn't
Oh,
matter.
underscore build.
Yeah, which is where you're running, right?
Okay.
I don't know, you can just write there, like, but that's just. Oh, I don't think it's that path. Expand the build, you will see the problem.
Uh,
You see the mess,
where is the
default,
executable located?
default, I guess. Bean.
Yeah,
Yes,
it is
from
in
library
here.
column, which is the main. Yes. So I think it will write there. So one, two, yeah, one, two. I think it, yeah,
Okay.
yeah. Just write to temperament. All right. So
uh,
the table name, do dot ndf after. Let's just do a convention for that, or we choose your extension. What is going to be your extension, Amos?
wait, I don't understand. Oh, the dot. Well,
Yeah,
it's
I
gonna
vote
be
for NFE. NFE.
NFE,
Yeah,
and that stands for.
Nathan's files extension. Just because I wanted to.
Not today, but that's a good idea to
Oh, we
trigger
could we
Nata.
could come up with another name later. Well,
Um, for now, we can just say, I don't know. I don't know, bin.
NDF. That's the format.
NDF? What is that?
Well, NDF is the secondary file for the usual like secondary file for databases.
Okay.
So it is, and you ask me, okay, why is it NDF? Well, it's because the other format is MDF, so the next is N, right? So M N O P. So anyway,
Okay, so we open the channel. What do we do with that? Do we do a, oops, out, channel, I imagine right? No?
yeah. So okay, this is funny. You literally write like with fprintf to this channel. That's what you do,
Okay, so where fprintf lives?
and
Printf?
to the printf.
Fprintf, out channel, thank you. And then I
Mhm.
put the content.
Yes, you can even you actually you on the F on the end you format the content. So just remove the F. F print.
No,
No,
f
just F
print.
print.
It's
Yes.
file print then. Unbound variable.
That doesn't exist, so you need to do it. Okay. So just do the printf and then do an empty string. Oh, sorry, a string with the mask of the string.
Wait.
I think that's binary actually. So let me see. How is
Hello,
the
hello.
binary? Hello,
Hello.
Nathan. Nathan, do you know the
Magenta,
bytes mask on OCaml?
good. I remember we annotated exactly for that, Magenta. We had like two annotations somewhere, dude.
Oh, right.
The best part is somewhere.
Oh,
No,
here,
I
here.
think it
Alt
was a
bytes.
comment, right?
Oh, look at the chat, Lems. It's there. Alt bytes. Scroll up a little bit.
Scroll up.
Oh,
Where?
Uh, like open in bytes and out bytes, and then the stdlib and close out. Oh, the stdlib is where the stuff is.
I'm confused. Where are you talking about?
Open the chat on this public channel and scroll up a little bit
Oh. Okay, close
before
out.
the NPC Oblivion memes.
Now I see. Okay, really input. Why?
uh,
Man, this
I'm gonna
was
say it again. Copy the good stuff, not the bad stuff from Haskell. Good names, people. Good names.
well,
Uh,
if it was Haskell, we would have the really, really input. So
no, no,
it's
no. I found when we were looking before in the libs today, we found exactly like map to like
uh,
yeah,
what?
yeah, map to
On OCaml, you
reverse.
mean?
Yes, yes.
Not on the stdlib, right?
Not in there.
Oh, okay.
so just do alt underscore bytes, then you channel and the bytes. That's it.
Wait, can you
And then
repeat
semicolon.
everything?
So
Uh,
no. That is fine. The printf you don't need this. You just change the printf function to out underscore bytes.
out.
Wait, can you
I don't. I'm
can you
still
read the functions, dude?
I'm not understanding, Magito. Could
I'll
you?
send you the link and you open there. Oh, I can't copy the specific. Oh man, change fprintf. Oh, sorry. Change this function. Remove it. No. The rest was the same. Yes, just remove the yes, and then the name of the function is output underscore bytes on lowercase underscore bytes. Yes, and then you write bytes, and then you just need to pass. Yeah, but serialized row is int is an order, right? So you need to write in order.
What?
Like look at the type of serialized row. Hover it.
Oh, we
You
need
see?
to do a map.
Yeah, so you need to map in order stuff. Well, which is should already be. Actually, you can remove that on the serialized row already. Now that I think about it,
What do you mean?
like you don't need the position after you sorted, right? So you can already eliminate it from the convert row. So like list sort, and then you map to a list map. Second, yeah,
So I need to actually go here and change this
to a byte list.
to that, and then we can just do that. So what is the type of this? Serialized
Okay,
row.
semicolon,
What is the problem? This
semicolon.
expression, but it was expected
Oh,
to
but it is a
return.
list. Yes, you need to map still. But this causes effects, right? So semicolon you will need, but you also need to map, to iterate, sorry. Sorry, list dot iter. That's what you need.
No. So I'm gonna do a list dot
Or you do
iter.
a for loop to trace.
No, 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 no. Let's not derail the thing completely.
So just output bytes, out channel, and then just exactly the order there, but with parentheses.
Oops.
The first two.
Wait. You said to do what?
Parentheses on the first two. So the following line, just move it to there, exactly as it is. Yes, and put a parenthesis between the first two elements to curry. Yes, that's it. All right, that's it, Lemus. No, you don't need now. Oh, okay, you do actually because yeah, you don't. It's since the last expression, you don't need to put this
Wait, folks. What is the list thing there?
list. What? Which list?
Wow, apparently you guys have a list somewhere.
Oh
The
yeah.
serialized row. That's a list. It's a list
What is
bytes.
a list?
List bytes. A serialized row.
Okay, because convert row gets you a list of bytes.
Yes.
Why not just bytes?
Hey, it could concat. That's true.
They have specific functions for building the array of bytes.
So do a map. Oh no, sorry. Just pipe through list concat lems on the yes. No, you keep that
Oh, sorry, that's true. I need to pipe again.
and then yeah, list concat. Oh, there's a concat map. That's interesting.
Oh no, but it's probably not this. Yes, yes. Screw you. Is that it?
Okay. Yeah. So now you don't need Twitter.
Okay, so this is actually wait.
It is still a list, of course.
Oh, all right. That's
You
like
have
just to
specific
squash. Oh,
bytes.
yes. Never mind. That's just to squash a list. Ah, you will need to fold. Oh, did it? Just keep it the way it
No,
is.
no, no. You don't need all those things. Go into bytes. They have functions for that. You
Ah, who
don't have
cares
to
then?
mess with lists if you want.
I don't want to burn my brain looking at the library.
Okay, so let's see if there is a way, reasonable
Let's see
way.
here. List.
Unsafe conversions. I love that the first section is unsafe conversions. I love that.
Let me look about the type annotation. I'm getting like a kung fu. So bytes, list,
Do we have
true
list in here?
bytes.
Oh, we do.
Ah, so there is a concat
Oh,
that keeps the
there is a
bytes,
concat specific for this. Yes.
concatenates the list of byte sequences SL, inserting the separator byte sequence between each.
Yeah, I guess they have
The end.
something better, dude. I let me see. But well,
I mean,
that works.
just keep it that, man. That works.
Just keep it like that. That
Yeah, just
works.
remove the concat. Just keep a map.
Oops.
Probably they do something to be efficient, but who cares? Okay, now let's retrieve Lemos. Oh, first of all, do you want to try to see if it's writing? I think that's a good idea. So let's do the
Let's see.
following.
Let's see if it builds
Instead of
also.
running on the top, run on. Okay, you can run on the top. I would say run on main, but that's fine.
No, I think we should run on main. It's so tedious to have to all those lets
Yes.
again.
Well, but you already have the
Oh,
command.
but we already have the lets. Yeah. So
Yes.
screw future Magita.
Oh, you just copy the commands from the top and paste on the file.
Okay. So we need the table first. No, we actually need to open all
Yeah, I
the
need to open
crap.
the jump.
Unbound module IO. Oh, I need to open Camelot first. The order
Oh yeah.
matters. This,
I complain again.
that.
It's beautiful.
Well, I'm learning from you, Magita.
Just a sec.
The AST. Okay, now we do the table, which is
Sorry.
this, and then we do schema. And let's actually not make the schema a function. Cool.
Yes, thank you. I don't know why I did a function.
um, and then we need we need the row, which is this.
Yeah.
Cool, cool as well. And now we do write on write row on disk, and the parameters are the schema, the table name.
I think
So
you can complete if you press tab.
and then we also need the row and this and go.
Okay, now check on temp. If it is open on Emacs, by the way,
Okay, let's open an Emacs. That's actually a good
because there's
idea.
a mode that is cool. So
There is a
yeah,
mode that is cool.
yeah, you'll find it cool. I hope.
Um,
Person,
so person,
is it there?
yeah.
Okay, enter. All right, now press Meta X, Hexel mode. Yes. So it didn't write anything, but keep it open like this. You can just refresh. But why it didn't write? Oh, you
Uh,
didn't close. Okay, you need to close the channel.
Wait,
Go back there.
I forgot the shortcut to do this. Does this still work? No.
Control X, B.
No, that's not what I want. I wanted to do something different, but I guess I'm forgetting some of my
Control X,
shortcuts
arrow
because
left.
I need to do more Emacs. Here. So,
Eat after the eat, you close the channel. Oh man.
close, out,
Close out. Yes.
and then out channel.
Yes, there's that nowhere that you saw. Because the correct way would be writing this in a try catch. But yeah, just keep it like this. Let's see.
just, just keep it. Oh, okay.
Dude, copy this command. Copy no. Copy the commands, please. Paste on main and let's run in there.
Cool. Copy. Main.
Yeah, comment this so you don't lose it.
Then let this, that, this. And
Oh,
the copy didn't work at all for some reason.
they
Let's try
they
that
opens
again.
as well. I would say. Yeah, that's okay.
Oh, the opens as well. Copy.
Yeah, Camelot is already open.
Yeah, but why it is not doing?
Mm, that's so strange. It's like as if it's not sharing
The buffer, right?
the
I
copy
wonder if I
buffer.
can copy to Discord. Is this a bug on Emacs? No! That's a bug on Utopia.
What? But no, but what? You're outside the top already.
Oh yeah, that's true. Okay, let's try to copy individual lines then. See if that works.
Let me see what Nathan is saying. For the record, the
No.
concat bytes stuff. Good choices are either that, add bytes, and then it picks a T, which I suppose is the list, and then
Okay,
bytes.
you do the copy pasting. Oh, there's not gonna be a copy pasting, I guess.
Oh, dude, this is.
I don't know why,
Uh,
but I can't copy.
do the following. Let me screenshot this, and then macOS can do it for me.
Oh,
But I'm not on
that's
Mac
cool.
though, so
Oh,
we're
I
gonna
got
wait.
it. So it needs to
Oh,
be
you
Control
did.
Shift C.
Okay. But why
Okay,
were you like right clicking and it wasn't copying? It
I
doesn't
have
make
no
sense.
idea. So here we need to do open some stuff. So open
I can
IO.
open there, right?
Can't open here. You said.
Yes, you can't open inside the latch.
Oh, okay. So let's put that in there. Open also
AST.
AST.
Yeah.
Okay, and now we do this, which is a bunch
Ugly.
of that. And then we need to do the schema. Oh, that will not work. This, okay, in. Then we do the row, in, and then we do the
Right.
right.
Mm-hmm.
Oops, that, and then that. Okay, let's see if
Double.
it builds.
You don't need to, by the way, on the semicolon.
Why?
Because look at the function, the pattern match.
Look at the function and the
It's
pattern
pattern
match.
matching what?
Unit.
Yes, so you don't need to add the semicolon.
I'm gonna add it anyway.
Don't know if that work. Oh, that works. Okay. At double. Okay, that was thinking. Never mind.
Okay,
Okay, run.
now
Like Dune exec.
Why do you have OpenFSHA
That's we were just implementing our own standard library. Like
yeah,
called FSHA?
Yeah.
Yes.
Sure.
So just okay, you need to pass like CamelotDB. Okay, now see if it updated the file. So revert the buffer. No, only max, dude.
Oh, on Emacs.
Yeah, you had it open you had opened the temp file.
Oh, contracts B. We
Yes.
want NDF.
Yes. The matx revert.
Revert buffer.
Yeah. Yes. There it is. I get that. But the name what? We didn't write the age, did we?
Uh, I think that's wrong. Yes.
Oh, you are probably just overwriting the thing
Oh, we're
with
not
the.
changing the offset. That's true. Oh,
Ooh.
geez, I thought the offset moved. Oh no, man. Oh no, no. This is a joke. Man, like
That's great, actually.
I thought the offset would move by itself, but it doesn't. Man,
Bytes.
why?
Okay, so it
Why?
is. It tries very, very, very poorly to do low level stuff. Then.
Man.
I think you are not getting it. If he was doing that, then that's not low level, right?
That is low level. That is expected behavior in low level. Even in C.
So
No, you are
here.
managing to him the thing.
Here. So what we need right now, if we are not gonna concat, which would be easier, but we're not gonna be able to just rely on concat anyway. We need to seek.
No,
So
just concat and write once. It's literally one function. It's
yeah,
bytes
okay.
dot
But here's what
cat
I'm
or
saying: we
something.
need to seek anyway later. So we have two options. Like seeking, we're gonna have to do later anyway. Just telling you. For
Wait, what
writing
does
again,
that
we
mean?
just need to write once.
Magetta is talking. I don't know what. If I understand what Magetta is saying with seeking, do you mean using that for reading?
Okay,
Like,
never mind. We can read in chunks, right? So it doesn't read. No, but we are gonna have to seek. Never mind, because we need to know exactly the
Maggot,
position that we
if
stopped later to start
Yeah, but
reading from that point.
what that has to do with anything related to doing the concat with bytes?
What
That's
I'm
the
saying
question.
is we have right now two options, which is concat all the bytes and write at once, which is more efficient, or
Yeah.
we just do a dumb thing and know already how to use the seek.
wait, can you repeat the
Oh,
last thing?
yeah. What
Or
he's
just
saying,
do a
Nathan,
dumb
is
approach and learn how to use the seek. But that's it. Like just do the concat for now. That's it.
No idea what you mean, dude.
yeah. I think I know what he means. Um, so we're gonna do what is it
Because if
called?
by seek you mean anything of related to read afterwards, it doesn't matter how you are writing the thing.
Concat.
What are you talking about, dude? I didn't get it.
This seek, are you talking about some kind of read that you want to do afterwards?
I'm saying we're going to have to do later a seek to read at an exact position, right, in the file.
Sure.
So I'm just saying the other dumb option is using the seek right now to write, which is not it's not the optimized way. I know this, but I'm just saying, okay, that was a possible choice for us to know how to use the seek, but that's it.
Oh,
Oh, like, oh, I want to write in that row, not
Yeah,
the.
exactly. Yeah, but not. Yeah, but we have to do this as well, right? If you're updating, but right now we don't, so that's not a problem.
yeah. So
So
the first
this,
problem is that I just noticed that
mm,
the concat expects a separator.
yeah, just press nothing.
An empty byte, dude.
Bytes empty. Can we do an
Sure.
empty byte? Oh, there is. But wait, you still need to extract the key, right? You
Uh,
need to pick the second.
by the way, don't you have bytes.cat or something?
You still need to map Lemus.
The cat just do concat, like uma concatenation. It is like pick two pieces of bytes and concatenate them together. Nathan.
Oh, not a list, right?
Yes. Can you
You
repeat,
still need to
Magetta?
map. You still need to map second.
Oh yeah, that's true. Sorry. List map snd.
Okay.
Okay, now the type is wrong. So now we need to go to this and just say
Yeah, just delete
bytes.
it then. Just delete it then.
So you can just say screw you Then we can just say screw you.
Yeah.
Magenta, what is the function that you use to convert stuff, like int to the bytes things?
To convert stuff int to the byte. Oh, okay. I don't know the function. It's there. Can you show
Can
me?
you take a look, Lemos?
One sec. Ctrl X B,
Oh,
NDF, revert.
yes.
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 Oh,
Yes again.
Right, it's
It's
wrong still.
still.
It is still
Yeah,
wrong.
that's. Can you print the byte as well on the go
Uh,
main and print after you serialized? Oh, you're serializing on line down.
wait, can you repeat?
Line 13 down.
Oh, you're talking here.
Yes.
So I already forgot how to do the print stuff. How do I print? This is
Well,
on
just
main.
yes. Format,
Print.
set, print and
Yes.
line.
Yes.
Yeah, but wait. But that is with the PPX, right? I think there's already a print bytes, man.
Okay, print
Print bytes.
bytes. Serialized row. I guess this and I guess this.
Yeah. Yeah, but let's just see what's the function we're using to serialize the thing.
yeah, I already saw it. Like it's set stuff, right? Uh,
Oh yeah, set int and e. Yeah.
so yeah, you would be able to do that thing, dude. Like initialize a huge one that you already know the length, and just like go mapping. Well, not mapping, like iterate on the string or int or whatever, and just setting with the correct offsets, right?
Yeah, that's what we're gonna be
Mm-hmm.
doing. That's very close to what we will be doing with the seeking.
Uh, this SIG doesn't go into that, dude.
Yeah, the seek does exactly that, but instead of writing is reading.
No, no,
Oh, but
dude.
it can be
That's
for
regarding
writing.
writing. The SIG that Magneto was talking about is regarding, oh, where do you want to write? Because you will not just write anywhere in the file.
No. What
If you
Magenta
want
was
to
saying,
update
No, no,
something,
it can be
like,
both. It can be for read as well, which is
Yeah,
more
it can be
useful,
for,
but
yeah.
write as well if we want to update, for
no,
example.
yeah, it's the thing about finding the place to do whatever.
Yeah, that thing about finding a place of doing whatever, that's what is common between the one way of doing the writing and the seeking. That's what he's saying. So what you
Well,
wanted, can we execute this? Did nothing. Oh no, it
Yeah, it
did,
prints the
Magenta.
magenta. So the number is disappearing.
Yeah, so we have a problem or in the convert row or in the convert literal. I think it's in the
dudes,
convert.
are you guys reading, like, considering the order of the bytes and stuff?
What do you mean by the
Uh,
order of the bytes?
Like the Indianness? Could that be the problem that you guys are finding strange?
Wait, I still don't
Or,
understand what you mean. Can you rephrase that?
yeah. You write the bytes in a certain order, right?
You write the bytes in a certain order, yes?
So, depending on the, well, I guess architecture that you're using, you could write in a different order. Or
Yeah,
you
but
are
we
not writing at all.
but we're not doing that. What we're doing is we are defining the order based on the position. So
Wait,
let me
what is
explain.
wrong with the output that you saw?
The problem is that this should be Magetta and a number,
Oh, sure.
yeah, which is the age, right? Oh
which
wait, did you add on the you added the age, right? In there.
yes.
Yes, ages. Can you format this file?
Uh, I
Yeah,
forgot
that one.
that
Yeah,
this is
that
the
one.
one. No
Oh,
formatting changes provided.
you need to install the.
Immediate
So
reaction
the
Magetta.
immediate regret. Then.
Yeah, anyway, so the problem is that we are seeing Magetta, but we're not seeing the age, which is 24. We're seeing the name, sorry. You're seeing the name, but you're not seeing the age. So that leads me to believe that, or, but the problem is that we tested this convert row function already.
Yeah, and it was
And we
speaking
know that
both.
it worked.
Yeah.
So I believe the problem needs to be in these two new lines.
Can you print the results on there? Do the following. I'll do what time. So instead of using like logging or debugger, just do a pipe to a lambda.
Just do a pipe to a lambda.
Yeah.
Oops.
Fun x. You don't need parentheses there, by the way. But anyway, so fun x, and then you do x, go back one, semicolon, and then you print x there. Okay, but this is a list of bytes, right?
Yeah, but we should be fine
So you
printing a list, I
list
assume.
iter. So list iter, print bytes, x there.
Magueta,
What
Magueta.
the heck? I'm very confused.
Magueta, Magueta. Okay, so that means that we lost the value.
How? That's the question. How?
Magueta, Magueta. We lost the value. We lost
I
the
don't
value.
get it.
Okay, so I
Let me
actually
see.
want to do the following. This,
Okay.
but
Yeah,
it will
yeah,
not be
just
print
change the
bytes. It
function.
will be print what?
Uh,
Ah,
well, it is a tuple now.
ah.
Yeah.
I'm completely disgusted not having the
What
first.
about printing inside the folder?
What about printing outside the fold?
Yeah, just print the result of the
Ah,
convert to
that's
true.
that's an option, but I actually think it's easier to just do this.
Yes, it is.
B, and then we can go back to print bytes, and then B. And how do you do the renaming, Nathan?
Oh, just do
S,
B then.
S, X.
Okay.
Does that
S,
work?
X, yes.
But why is it
That's
failing then?
good. Parentheses all over it.
It's still failing.
Why is it?
Unbound value B, these parametric
Oh, it's a
values.
list.
Back.
Because it's a list, you can't pattern match like this.
Oh, okay. So I need I need to actually do this fun stuff here.
Yeah.
So this B,
First.
this B, and that. What is
It's
the
gonna be
freaking
X,
problem
right?
now, my
Oh
friend?
yeah, that's B, but well, iter, you need to pass X to iter.
No, sorry. Okay, okay, that
I
should
don't
be
think
enough.
this is gonna work, but let's see.
Mageta. So
Yeah.
that means that the fold is losing it.
How? That is a good question.
How is the fold losing it? How
Can
is
you
the
print
fold?
on the V integer branch? Just print like here.
Sure. V integer branch.
Yes, there.
So print
I should have
string
fallen there then.
hello.
Kitty.
There's a
Hello.
hello. There's a hello there.
So it entered there, but then what?
There's a hello
Can you
there.
print serialized value? So
Yes.
yeah, move the yeah.
So print
Bytes.
bytes serialized value. Oh,
So the
is my
value.
terminal trolling? Is the value here but it's
Ah,
not printing?
Try on Emacs. Just for
could
try
it
on
be some
eShell.
flush problem?
He's gonna try on eShell. First, we're gonna
uh,
be
do
need to go back. You need to go back.
Dune, exec, CamelotDB.
I will laugh hard if it is. If you
Oh! It was trolling! Look!
oh wait. No, but wait. It's not writing on Emacs, here, right?
It was on what?
I think. Can you do a new line before
Before the
on
print?
the on the hello? Do a new line, and
Sure.
then before you print and after you print again, do a new line again. Print and line. Yeah.
And oops.
Uh. Uh huh.
Oh, I need
Oh,
to pass this.
it receives unit, yes.
What the?
What? What the fuck?
This
No,
no.
no.
That's new.
Ctrl X U. What the fuck? What happened?
Interactive progress must be careful about flushing standard output and standard error.
What? Okay, Ctrl X U. Go back. Go back again. It doesn't. So carefully kill the file and don't do this. Carefully do this.
You want me to close Emacs?
No, no. Carefully just kill this file.
Ctrl X K.
Ctrl X K, yes, and don't save. Please don't save. Yes,
Modify.
kill anyway.
Yes.
Okay, now open again. Dude, what the heck happened?
That was weird.
That was really.
Okay, print string. No, print new line. This.
You're losing
Cool.
sanity here. And after you print the bytes. Alright.
Ctrl X B. E shell. Doom build.
Huh.
Nagata,
So,
could
so
it be the way you are writing and reading stuff? Like in incompatible ways?
no, I really think not done. That this is just my terminal trolling.
Yes, it should be showing there, but why
Isn't
isn't it
just
showing?
age?
What?
Isn't just age like numbers?
Isn't
Yes,
just
it is
age like
numbers.
numbers? Yeah, but
And
it's
I
in
guess
byte
that's
form.
the X there.
So, I mean, the chance of your
Oh
terminal be
wait.
trolling with
Oh
numbers?
dude, wait. What is in ASCII? What is X? Capital S X.
Uh,
So
okay,
X.
so ask table. Uh,
You are
so
probably writing.
okay, so capital
Hmm,
X is 68. No, 88 in decimal.
Yeah, that's totally off.
you're
58.
writing everything as ASCII, but writing as an int maybe?
Yeah, look at the hex cell. Sorry, hex. It should be. Is there anything? No, dude, no, that's wrong.
Oh,
Yeah,
convert.
there is there, but oh, and then look at there. Like Magenta ends on M, 1, 2, 3, 4, 5, 6, 7. There are 7 letters on my last name, and then there's 1, 2. Okay, thank you, Linus.
Sorry?
Okay, we can try to read and see if it is still there. I don't
No,
know.
no,
Maybe
sorry.
it's just a
I didn't
visualization.
notice you were counting. Sorry, I was
No, no,
just
never mind.
trying to understand
But
the error message there down there.
I think the visualization might be not showing, but I think it's still there. So we can try to retrieve the information deserialize and then see if
Yeah,
we
that's
get
kind
the
of a
number.
gamble, I guess.
Well, that's fine. By the way, folks, I really need to have dinner.
Yeah, so I think
Really?
we are cool because we already are. We have 2 hours, so today was fun. We did a lot of stuff. Okay, so I talk to you guys later. I'm gonna finish the stream as well. Okay.
All right. See everyone.